Interference. Okay, so here I have the two waves which interacts at one point. Okay, where the two waves meet or hit or when it cross, so that is called interference. Okay, which means the wave will interact with each other, so that is called interference. And we have the initial and final difference between these phases. This is phase 1 and this is phase 2. So this is called phase difference, because from the initial it has some place, and to the final say you have some distance, so that is phase difference. So you can divide this interference into two types. One is constructive and another one is destructive. So constructive means is nothing but where you can create the waves, and destructive you can destroy the waves. So to find out the displacement of a wave, to find out displacement of wave, we need to find out the amplitude. So amplitude formula, what we will use, y1 is equal to a sine omega t. So here I am I have two phases, so I am taking y1 and y2. So here also a1 will come, and y2 is equal to a2 sine omega t. So we know already why we are using sine omega t for the amplitude, because we studied that thing in the 4th lesson itself. And to find out the total displacement, so for this interference we will use the superposition principle, where we have to add sum all the vectors in the electric field and also in magnetic field. So here also the same thing, we need to add it. So y1 plus y2, so total displacement y1 plus y2. So y is equal to, just apply y1 value, y2 value here. So a1 sine omega t plus a2 sine omega t. But in this case, for this y2, I am going to just add plus 5. Y means for the phase difference. So in the initial I have sine omega t only. To calculate the total phase difference, I need to take this phase difference. This angle as a phi. This path difference as a phi. So here also I am going to apply that phi value here. Omega t and phi. So we have one trigonometric relation. So the formula is sine a plus b is equal to sine a cos b plus cos a sine b. So this is the trigonometric form. So here also we have the same thing only, sine a plus b, omega t plus phi. So we are going to apply this thing in this place. So we will get y is equal to a1 sine omega t, as it is. I am writing as it is, omega t plus a2, note it carefully, a2 sine omega t, because of the sine a. Sine a sine omega t. Then what we have, cos b. So we have to write, yes, cos phi, and again we have the plus sign here. So plus a2. Again we need to take this a2, and the formula will be turned into cos omega t and sine phi. I have just applied by using this trigonometric relation. So in this case, I am going to take this sine omega t and this sine omega t as a common. So this equation will be turned into y is equal to a1 plus a2. And this cos phi. So in the bracket, outside the bracket, I am writing sine omega t plus the remaining terms. So what are they? a2 sine phi and cos omega t. I have written as it is. I didn't change anything. Sine phi and cos omega t. So now this a1, a2 cos phi, I am going to represent it with new term. Just I am going to implement the new term. So a1 plus a2 cos phi is equal to a cos theta, and keep this equation as 1. And then this a2 sine phi is equal to a sine theta. Okay, so only this alone, a2 sine phi. So just we are going to apply this term in this equation. So the equation will be turned into y is equal to, okay, so here I am writing a cos theta. Instead of writing a1 plus a2, I am writing a cos theta. So a cos theta sine omega t plus a sine theta. Instead of writing a2 sine theta, I am writing a sine theta, and the remaining thing cos omega t. So before that, take the a as a common. So we will be getting a open bracket cos theta sine omega t plus sine theta cos omega t. So it is in this format, no, the trigonometric relation what we saw before. Okay, so this is in this relation. So I can write sine a plus b. So here we have the omega t plus theta. So instead of writing sine a plus b, I am writing here, see here, listen carefully, y is equal to a sine omega t plus theta. Clear? So see this relation, sine a, which is here, we have theta. For cos b, we have omega t. So like that, in the same format means I can write sine a plus b. So here I have the angle omega t plus theta. So I have written sine omega t plus theta. Okay. So now to find out this is the value for the resultant displacement. And we are going to find out the intensity. So when we will have the I intensity. Okay, so the intensity formula is I is directly proportional to a square. So which means the intensity is directly proportional to the amplitude. Okay, so we have the amplitude relation here. Okay, this two relation, equation 1 and equation 2. Okay, so just we are going to add this two relation. So the equation, the intensity formula is I is directly proportional to the a square. Okay, so just we are going to add the two amplitudes what we have derived so far. So a1 plus a2 cos phi. Okay, okay, and a square cos square theta. So why I have squared these things means because we are squaring the amplitude. So y is equal to, we have the value without the square. To now it is directly proportional to the amplitude. So we need to square the terms. Okay, while we are adding. So the second term is a2 square sine square phi is equal to a2 sine square theta. So we are going to add this. So before adding it, so this is in the format of a plus b the whole square, this thing. Okay, this is in the format of a plus b the whole square. So I can write this thing, a1 square plus a2 square cos square phi plus 2ab only, no. So a1 square, not a 2ab only, no, a1 a2 and cos phi will come. Okay, and the remaining term what we have here plus a2 square sine square phi, that's all. Okay, and in this side, the right hand side, we have equal to a square. Okay, listen carefully, a square and the cos square theta, and what we have, sine square theta. Okay, a square as a common. Okay, so now for this term, cos square theta and sine square theta, the value will be 1. Okay, the value will be 1. I'll write here value. Okay, and this sine square theta and cos square phi, sorry, sine square phi and cos square phi will have the value 1. So we are going to write the remaining thing here. Okay, so what will come? A1 square plus A2 square plus 2A1 A2 cos phi is equal to only this A2, because this total value will be 1. Okay, only this A2. And I'm going to change this equation as A1 square plus A2 square plus 2A1 A2 cos phi as a and taking this as a root. Okay, and now when we'll have the maximum value? Okay, when we'll have a that amplitude will have the maximum value. For that, A maximum is equal to what we have here, A1 square plus A2 square plus 2A1 A2 cos phi we have. So instead of writing cos phi, sometimes we'll have the value like 0, 2 pi, 4 pi, means the phi value will be 1. So when I am applying 1 here, okay, so it will be in the format of a plus b the whole square. Okay, it will be in the format of a plus b the whole square, but the value will be 1. The sign also will be in the positive. Okay, the value will be in the positive. Okay, for this case. Okay, a plus b the whole square, because I have applied the value 1 into 1, 1 will come. Cos phi in the place, if I applied 1 only will come. Okay, so then I will have the a plus b the whole square format. So a maximum is equal to root of a1 plus a2 the whole square. Okay, only for the value like 0, 2 pi and 4 pi will have the positive value. Okay, so which means the wave amplitude. Okay, so here like this it will go no, positive, negative, like that it will come no. So that's what they are telling it. But when the value will be minimum, it's opposite. What will come? So a1 minus a2. So which means it clearly denotes that the same thing only will be there, but the value will be like 3 pi, 5 pi and only pi means, so you will have the value like minus 1. So phi value will be minus 1. So here I have a1 minus a2 the whole square. Okay, so the value will be destructed, which means destroyed when we have a1 minus a2, and it will be in maximum when we have a1 plus a2 the whole square. Okay, and we have the amplitude formula. Okay, so just we are deriving in that only. So again I am writing the amplitude formula, a2 cos phi, without squaring it. Only for the intensity we need to square the amplitude formula. For this case, don't square it. So is equal to a cos theta and a2 sin phi is equal to a sin theta. So here I am going to divide this equation 2 divided by 1. Okay, second equation I am going to divide it with 1. So what will come? Sin theta by cos theta is tan theta. Okay, sin theta I will write here. Cos theta is equal to tan theta. So tan theta is equal to a2 sin phi divided by a1 plus a2 cos phi. Okay, so just I have written the equation as it is, but I have written the second equation as first and first equation as in the denominator. Why means we are dividing the equation 2 divided by 1. So we need only the theta value. So theta is equal to tan inverse a2 sin phi and a1 plus a2 cos phi. So here I am going to write I is directly proportional to I1, because I am going to take this A1 square as a I1. Okay, take this A1 square as a I1 and A2 square as a I2, like that. Okay, I3, I4, how many amplitude you have, like that you can take intensity only, no, because that is amplitude. So I is directly proportional to I1 in this equation, I1 plus I2, yes, plus 2. So A1 means it's nothing but I only. A1 means I only, because I have the formula directly proportional to a square. So when this root comes this side, I will get root I. So here 2 root I and again the root I2, I1 and I2 and the remaining cos phi will come. Okay. So if the two amplitude are same, okay, if the two amplitude are same, A maximum is equal to A1 square plus A2 square plus 2A1 A2 cos phi. Okay, so this is the A maximum amplitude value. If the two amplitude are same, I am taking this A1 and A2 as a A1 square or A2 square or A2 A1 something. I'll take A1 is equal to A2 is equal to A. Okay, I'm going to take that as an A. So A maximum is equal to root of, okay, here one A, here one A. So 2A square plus here one A1, A2. So 2A square and the remaining cos phi. Okay, so again A maximum is equal to root of 2A square, take as a common. So remaining I will have 1 plus cos phi. So now I can write this cos phi as 2 cos square phi by 2. Okay, so now this equation will be turned into root of 2A square, 2A square and write this 2 cos square phi by 2. Okay, and remaining what we will have? Not remaining, the next step what we can substitute, add this 2. So 4A square and cos square phi by 2. Okay, so here the intensity is directly proportional to the amplitude. Okay, so I can write the intensity is directly proportional to 4A square cos square phi by 2. Okay, so this is the intensity and this is the interference topic also. So the phenomenon of superposition two light waves which produces increase in intensity at some point and decrease in intensity at some other points is called interference of light. To find whether the wave is created or destroyed, we can able to solve it by using this interference prediction. Okay, we need to follow these steps like amplitude, we need to square the amplitude. Before that we need to find out the intensity. After that to get the accurate intensity we have to implement that with the amplitude and we need to get the final answer like this. So the intensity is directly proportional to the 4A square. There A square, no, so the amplitude is 4A square cos square phi by 2. So this is your answer. Copy in your notebook, classwork notebook. Very, very important question. So first you write all the things, then you study. You can able to follow this notes. Okay, thank you.